In this video, you're going to learn what is a digital twin, how to create it, what tools can be used, how a digital twin interfaces with external systems, and what roles do technologies like AI and blockchain play in digital twins. My guest to explain all of this to you is Pieter van Schalkwyk, who is the CEO of XMPRO, a low-code application development platform that enables subject matter experts to build and deploy real-time applications in weeks. He currently serves as the co-chair of the Natural Resources Working Group for the Digital Twin Consortium, and previously he co-chaired the Digital Twin Interoperability, Industrial Digital Transformation, and the Distributed Ledger Task Groups in the Industrial Internet Consortium. He holds a bachelor's in mechanical engineering and a master's in information technology. In 2019, Pieter received the Industrial Internet Consortium Technical Innovation Award. Our discussion is based on his ebook, The Ultimate Guide to Digital Twins, which I will link down in the description below. Welcome to the fourth generation podcast here on Industry40.tv, which is a series of interviews designed to help you learn industrial IoT from some of the world's leading practitioners. So make sure to subscribe to never miss any of the interviews. Now, here's my conversation with Pieter. Okay, welcome to the show, Pieter, and thank you so much for joining us today.
It's my pleasure, thank you.
So I think we'll just jump right into it. To begin, perhaps you could briefly explain to us what is a digital twin and what problems does it seek to solve?
That's a great question. It's the first question I always get. What is a digital twin? And I think in its simplest form, it is a virtual representation of an entity. That's a very simple one. But I think if you expand it a little bit further, it's really a synchronized instance of a digital model or a template that represents an entity throughout its life cycle, and it's sufficient to meet the requirements of a very specific use case that the digital twin is meant to address.
Okay.
I also think, from the problems that it is meant to solve, the original intent by Dr. Michael Greaves, who's kind of the father of the digital twin, was really that you could create a information construct for a physical asset. So the intent from their side, specifically working with NASA, was that it could provide the same or better information that you would get than having the physical thing with you. So it was all around systems that are getting more complex, and how can we reduce the complexity by creating a digital version of it. And what we see right now, kind of the main uses or main objectives and problems that it addresses is really around how can I get more situational awareness around what's going on. So how can I get better insights into how a physical thing would behave, and how can I make better decisions based on that model that I have, and that represents the real physical entity and its operating conditions.
Oh, okay. You mentioned something to the effect that a digital twin is an instance of a digital model. Could you please elaborate on the digital model concept and also on the aspect of instantiation?
I think those are two very key aspects of having a digital twin. So you obviously have to have the physical thing, but then you also have to have a model that would describe that, basically the information model or prototype or template, or the way that that would describe the physical thing. And then I would have instances of that. So the best way is to describe it by an example. If I have, so for example, for a Tesla Model 3, there is a type or a template that describe what the Model 3, all the components that it's got. And then I have, and there's only one of that describe this is a Model 3. I may have 1 million instances, which is unique to every single car that is built. The real-time data that's getting from telemetry information that around the color. It is unique per vehicle. So there's a unique instance or unique instance identifier, but it relates back to a model that says this is how I store the information and this is how I interact with that information based on my template for that. So that is the model and the multiple instances on that. For some types of equipment like a building, you will have a model, but you'll only have one instance. So it doesn't always have to be multiples, but in most instances it is.
Oh, okay. Yeah, it makes a lot of sense now. So in your ebook, you sort of mentioned the different categories and types of digital twins that are available. Could you perhaps describe to us what are the different types of digital twins and the different categories of digital twins?
So we kind of see three main use cases of digital twins. The one is, or types, if you want to call them that. The one is around just status monitoring. We call it a status twin. So it's a single direction. I'm just getting real-time data that represents this is what's happening to my twin. So I can get the status of an operating plant, a machine, a building, or anything that I want to, even a supply chain. I don't interact with it. I don't create any actions coming out of it, which is kind of the second type, which is what we call an operational twin. This is when the twin also has some intelligence where it can now interact. It can create actions in other systems. It can create work orders. It can update supply chain information and basically interact. That is what we would refer to as an operational twin. So it becomes part of the operations of a business. And then another key use is when you have or use a twin for simulation. So I can get some real-time data, pass it to a model. It would run a number of simulations, and based on the output of the simulation, I would then take a decision on what I want to do from a decision point of view. And again, that is the simulation twin. So status twin, operations twin, and simulation twin are the three main patterns that we see of digital twin types.
Okay. Also, those would be the categories or the types of digital twins.
Yes.
Okay. All right. One thing that I'm really curious to find out is on the actual nature of the digital twin itself. That is to say, what is the actual makeup of a digital twin? Is it a file, or is it some database entities? What is it that makes up a digital twin? And also, to follow up on that question, what sort of infrastructure is required for you to have to facilitate the existence of a digital twin?
Again, that's a great question. The nature of a twin and how you constitute it really is dependent on the use case or the application that you're trying to. I sometimes refer to, what is the job that you're hiring the twin to do? That would determine the nature. Now, it is certainly not a mega single database file that contains everything. There are different ways that different companies and organizations implement this. So sometimes, and if you look at the standards and information models that are emerging, so if you take something like asset administration shell or DTDL, so some of them might be XML based files or JSON based structures. We still see the predominant mechanism of storing this is through a number of different relational databases. One of in terms of the evolution that we're seeing around that is graph databases, so that twins are starting, so we can understand relationships on that, so that the data itself or the relationships are stored in a graph, but the underlying data coming from telemetry or some of the master data, or the equipment data, the maintenance records, all of that tend to be in the systems of transaction. But the twin would know from a graph perspective where the different systems is, where the sources are, and again, those sources right now vary anywhere from file-based to relational databases to, for example, on Azure Digital Twin, which is a cloud-based construct, which is designed specifically to store a database. A digital twin and its relating data.
Okay. Also, like if you are to store your digital twin on a platform like Azure, you what you are saying is that you'd have some special kind of storage to handle that. So, and then when you decide to say you want to have that digital twin on-prem, what kind of infrastructure would you need? Is it some kind of special tool chain that you need to have for you to have a digital twin reside on-prem?
So, and again, it really depends on the volume of data, the type of data that you want to store, the frequency at what you want to do it, the fidelity of the digital twin in terms of how you want to see the information, again, how you want to be able to extract it. So for some very simple use cases, like some of the status twins, you can do it on something as small as a Raspberry Pi and store the data in file-based structure, where on some of the larger on-premise, you may go to a localized server environment. And again, storing the data on either relational databases or also non-relational, non-SQL style data repositories is something that we also see from our on-prem. There is a move to do some of the digital twin processing at the edge, and we're seeing a lot of growth in that area. And that is one of the areas that we see quite a lot of research and opportunity to evolve digital twins itself.
Okay, interesting. I guess my next question is what tools or frameworks are available for creating a digital twin, and what are the key factors that one should consider when they are embarking on that process of creating a digital twin?
So I think in terms of tools and frameworks, a digital twin is still a software-based product. So in terms of tools and frameworks, they tend to be based on tools and frameworks that we use in software development practices and software engineering. It is how that is applied to kind of model how physical assets are being done. We're seeing, and also there's a difference between the asset lifecycle, the physical twin lifecycle, and the digital twin lifecycle, which is more of a software engineering lifecycle in terms of how we do that. So in very complex systems, we see, or very complex physical systems, we see things like the V model from a software development approach in terms of how that evolves with complexity of the hardware. In other instances, we see more of an agile or a lean approach. We actually prefer kind of a lean startup approach from a framework perspective, which is more around how we can experiment, how can we build a minimum viable twin to start out with, test some of our assumptions. But not everyone has got that capability where if you have a high maturity, high complexity environment, for example, in aerospace or defense, you would follow a more structured approach from a software engineering perspective. With digital twins, we've not seen new frameworks from a software engineering point of view emerge, but we're seeing how they are being applied to this specific problem. In terms of factors to consider when starting on this journey, I think, as I mentioned, the most important one, what we've seen, is really understand the maturity of the team and the products that you are trying to create. So if you've got a very experienced development team and you've got all the requirements well defined, you may follow more of a structured approach. But if you're using your engineers in your business to basically experiment, a more of an agile kind of a lean, building a minimum viable twin to start out and kind of building from the bottom up is a better approach. Much lower risk than trying the big bets, rather go for the easy wins approach.
Oh, okay. Can you perhaps highlight like a series of steps that one would take towards creating a digital twin?
Yeah, I always say you start with a problem. So we've seen so many times where projects like this start with, we have this data, what twin can we build with it? We have seen very few of those succeed. So really the best advice in terms of steps is make sure that you have a problem that is worth solving, that it's got a high business impact, and that it's technically feasible to actually do it. So kind of start with a problem, and then look at what analytic or rules would you employ in the digital twin to solve that. So would you be using some physics-based models, or would you use AI or machine learning or something like that? So once I know what the problem is, what analytic would I apply? And once I know what kind of the rules are, or the analytics that I want to apply, I can then look at what data do I need to drive that rule or analytic. And as soon as I know that, I can then go and look, where can I get that information? So where are the data sources, IoT platforms, sensors, web services, all of those fancy things that we can use to bring real-time and static data into the twin. And once we have that, we can now start composing from the bottom up. Now we can start building it up back towards the problem, starting with, here's the data, here's the analytic, and applying that to the problem itself. So that is really the kind of step-by-step approach that we find has got the highest likelihood of success when you start out.
Oh, okay, no, that's interesting. Now, well, it goes without saying that a digital twin is likely not to exist in isolation. I mean, particularly in this day and age where we've got like different systems that are being built around the industrial IoT ecosystem. So my question is, how would an external system consume information from a digital twin? Is there any some kind of interface standards or some APIs that are available for anyone to do that, or anything that is currently in development?
So right now, there are no APIs for digital twins per se. So there's no standardized APIs. But if you look at a typical digital twin project, right now, anywhere from 50 to 80% of project time goes into integration. Is how do we connect the different data sources, both on the where we get data from and where we kind of pushing, the actions that come out of the digital twin. So a large portion of that, a lot of it at the moment is point-to-point integration using APIs, calling a service. There are tools that, like XMPRO, that is kind of a low-code approach to handling the integration, that are more integration-centric, or just doing it inside development environments like Visual Studio or Eclipse or one of those developer environments. In terms of standards that are emerging, there is work being done around interoperability, because one of the biggest challenges that you face with this is interoperability, things that don't really talk nicely to each other. So Industry 4.0 through the asset administration shell is one formalized way, or one formalized initiative that's looking at how to address this. And currently there's a set of standards being produced. Part one of 3 different standards was published towards the end of last year. Unfortunately, that just describes what the asset administration shell structure looks like. or the digital twin structure. In terms of the APIs and how they communicate, that is likely to come out somewhere in 2021. That will start addressing. There are other initiatives like the OSDU, which is the Open Subsurface Data Universe, that's predominantly in oil and gas. We're building subsurface digital twins, kind of what's below the ground, because again, I can't really go and see, so I need to build a model, and I understand that. There's been standardization efforts around APIs and how to standardize the data ingestion, and again, bringing that information out in a standardized way. But most other projects are really just point-to-point integrations using microservices, using APIs, but not through a single interface into the digital twin. That's only starting to emerge now.
Okay, yeah, that's interesting. Yeah, because I'm really of the sentiment that if without that kind of 100% interoperability, whereby these industrial IoT components are able to exchange information effortlessly, it will be hard really to realize Industry 4.0. So I really believe that's something that is key to whatever is development that is currently going on with digital twins. So now you mentioned something that is very interesting also in your ebook, the concept of a digital thread. So now perhaps to kind of clarify that for our viewers and listeners, could you perhaps compare and contrast between a digital twin and a digital thread?
Yes. Again, it's a question that we get a lot because there's a lot of confusion around these digital subjects or digital concepts. And a digital thread is typically the unique birth record of with the actual data for either an entity or a product and all its components. It kind of captures all the interactions from when it was started, how the design, right through to how it was manufactured, the conditions where it was stored, and how it was maintained and how it was disposed. So across the life cycle of either a component or a machine or even something as complex as an aircraft, we would have the birth to disposal record across everything. From a digital twin perspective, the focus, so that is a horizontal kind of life cycle view. From a digital twin perspective, our focus is we actually use some of the digital thread information in creating a digital twin, which is more, if you can just picture it, more horizontal. At a specific point in a life cycle, I may want to predict the likelihood of a machine failing. So I'll use some information in terms of real-time data, operational data from a production line, some weather data, some of that, and also the maintenance records, which could come from the digital thread itself. So the digital thread can exist without a digital twin, but more than often the digital twin will consume information in the digital thread. The best example that was given to me was actually from an engineer at Boeing, who said to me, when we decide on a fleet of aircraft, which aircraft to maintain, we go to the digital twin. It is hired, it is done around a specific use case to look at maintenance optimization of which aircraft should go in next from a maintenance point of view. When I look at the digital thread and I have a problem with one of the components, I can see exactly what the design was of that component, which other aircraft it's gone into, and I can see the whole birth to death record of a specific component. So if I need to go and find every other plane that has got that same faulty piece of equipment, I use the digital thread. If I know which one, if I want to know which airplane to maintain, I go to the digital twin.
Oh, okay, yeah, that's very interesting. So it seems to me that the digital twin is really centered around, I mean, even as you rightly pointed out earlier, that it's centered around advanced analytics like AI and machine learning. Could you perhaps describe the relationship between AI, machine learning, and the digital twin? How does it look?
Yes, so again, it goes to the job that you're hiring this digital twin to do. If it was a person in your business, what would that digital twin do? So in some instance, it would just be to observe, which is kind of what we said earlier with a status twin. It would just give me some very basic information. But we see more and more that we want to make these twins smarter. So how do we do that? We put in AI and machine learning capability into the twin to help us with decision support at this stage. So we would take some of the real-time data, and the job of the twin is actually to predict when something is likely to fail. So it would use a machine learning regression model or anomaly detection. And that is the intelligence that's being built into twins. And again, you could do that in using programming tools, or you could use a low-code environment where you basically drop the machine learning into the twin and say, at this point, take all this data and come up with a prediction of how many hours I still have before this thing is likely to fail. And that's how we see the twins getting smarter and how machine learning is adding to this.
Awesome. Okay, so another interesting combination is that of digital twin and blockchain technologies. Could you perhaps explain the merging of these two technologies? How does it work?
So we see two scenarios for blockchain with digital twin, and I'm sure more will emerge, but kind of the two major ones at the moment is if I want to make sure that my information around my twin is immutable, meaning it cannot be changed. So from a compliance point of view or regulatory point of view, I need to show, the decisions made by this twin, and I maybe need to go and prove it later on. So instead of storing it into a conventional database, as we discussed earlier, one of the ways to store the digital twin and its information is actually in a blockchain. And also validating where the data sources come from is another use for blockchain. The other major area for blockchains and digital twins is when we want that digital twin to interact. One of the big use cases out of distributed ledger technology is around smart contracts. So if we want that digital twin to interact on our behalf, when it receives certain information, when certain conditions are true, when certain things have happened, certain events have happened, we wanted to execute a smart contract, we can put that into the digital twin as well. In actual fact, we can combine machine learning, so it can predict that something will happen, and then based on that, initiate a payment in a smart contract for someone to go and deliver some services, all built into the digital twin, using blockchain and other emerging technologies like that.
Oh, okay, yeah, that's interesting. Okay, now to sort of like close off the session, I want to shift the focus to XMPRO, which is a company that you're a CEO of, and also I want to touch a bit on the Digital Twin Consortium, in which you are a member of. Now, first of all, could you please tell us a bit about your company's involvement in the digital twin ecosystem?
Yeah, so our focus is really, so XMPRO is an engineering-focused, low-code digital twin application development platform. And it's really aimed at engineers and people like that to be able to build their own digital twins, the three types that we mentioned. And it's really focused around addressing how we would respond to real-time events. So our focus is pretty much real-time digital twins that interact, and mostly in asset-intensive industries like oil and gas, mining, energy and utilities, and manufacturing, kind of key focus areas. And again, it is aimed at engineers to be able to construct their own digital twins. So that's been kind of our involvement. And our objective is really to make sure that people can build these to safely increase revenue in their business and reduce cost. We've been around this for quite a long time, working in Fortune 10 companies, helping them with digital twins, and also being involved with organizations like Industry Internet Consortium, the OSDU, or Open Subsurface Data Universe, as I mentioned, and lately the Digital Twin Consortium as well.
Oh, okay. Oh, yeah. So actually, meant to ask you if you had any kind of partnerships that you have going on. So I guess part of that answers that question about you partnering with the Industrial Internet Consortium. Is it a partnership, or what kind of relationship do you have, and what sort of partners do you have?
Yeah, so the Industrial Internet Consortium, I was the chair for the Digital Twin Interoperability Task Group, and in the newly formed Digital Twin Consortium, which is one of the fastest growing consortiums at the moment, I lead the Natural Resources Working Group, where we're looking at mining, oil and gas, energy and utilities. And kind of our focus areas there, again, is the interoperability problem. What are the typical use cases? So those are more member-driven organizations where we're involved, and we kind of volunteer our time and work with some of the brightest minds in the world on these problems. In terms of our other partnerships, it's predominantly around services partners who with strong domain expertise, strategic consulting expertise that can assist customers with deciding, what digital twins do I need, what would the impact be, and how do we go about putting them in. And with some of the engineering IP, those are some of the partners that we have. The others are technology providers like Microsoft and others, where we leverage underlying technology like Azure or Amazon AWS or some of those services.
Oh, okay, interesting. Okay, so now to close this off, I've got a series of questions. First of all, what is the Digital Twin Consortium? Number two, what are the primary reasons for the existence of the consortium? And if you can outline the efforts that are currently underway to effect whatever change you seek to make.
Okay. Yeah, Digital Twin Consortium is a member-driven organization under the OMG, the Object Management Group. They manage that. They're a standards body. The Digital Twin Consortium is not a standards body, but we are working to influence standards bodies on what the standards should be. So the primary reason for existence is a number of vendors and end users got together and said, we really need to make sure that we can drive interoperability, that people really understand what a digital twin is, because there are 50 different definitions depending on which vendor's website you go to. So, being the authority in terms of digital twins, the one place that you can go to understand, what is a twin, why should I care, and how do I get started, are kind of primary reasons why it exists. And some of the initiatives underway at the moment, it's also constructed around different industries, and we're looking at how the different industries are either the same or different. So infrastructure, aerospace and defense, manufacturing, and natural resources are the initial four main working group or working areas, and they're adding new ones as we speak. And our focus is looking at what are the use cases, applications, and value of digital twins in each of those. How are they similar? How do they differ? And can we come up with a reference architecture based on specific conditions or operating environments? And how would you use certain components in a technology stack to put together a typical digital twin? So that's kind of some of the efforts that are ongoing over and above standardizing the definition of a digital twin.
Awesome stuff. Oh, Pieter, thank you so much for joining us today on the show. Really wish you all the best in your endeavors, both as XMPRO and also under the Digital Twin Consortium.
Thank you very much for having me on your show.